Hello everyone, this is Brian and welcome to episode 6 of my Reusable Kerbal Space Program series. This game features engineering, putting pieces together, creating solutions, and then throwing them out in space and doing flying missions of your own choosing. So far you've only seen the flying the missions part. Tonight I'm working on the space station, trying to conceptualize it, figure out how I'm going to do it, and I got to solve a bunch of problems, and I thought it'd be kind of interesting to do that with you. If you don't want to see a lot of stuff in the VAB, then I will either record over this telling you where to skip ahead to, or just tell you to go on to the next video. And if you don't want that, please don't press dislike, just watch the next video. So I'm going to start off with a little bit of a status report, then we're going to the VAB, and I'm going to talk about how I'm going to build this space station, what it's going to look like. I've been solving some problems around it, and I thought it might be interesting to do so. It's going to take some time, and I don't want to leave you with weeks and weeks and weeks until the next video. So quick status report. Lathe Surveyor is right here. It is almost to its Kerbin SOI. It is, 47 days into its mission. And for launch windows here, we got the Duna launch window in about 35 days and the Eve in about 365 days, so there's a long ways to go there. The Lathe Surveyor is bugged right now. Last time I tried to switch to it, the game crashed. I hope that does not become a thing. It was working fine last night, except that the view focus is way, way off. So I'm not going to go over to that probe right now, but we will start with that in the VAB, and I'll give you a quick tour of that craft. Okay, here is the Lathe Surveyor in the VAB. This is the actual craft that is on its way to Lathe right now. And we'll start by just opening it up. Okay, so this body here, we've got a xenon tank and a procedural battery is kind of making up the body of it. We've got stabilizer down here. We've got a docking node if I ever want to dock with this and refuel it, maybe just send it elsewhere. And then on top is the probe core. And that's with procedural parts, which is why it looks funny. Now procedural parts, I'm kind of blaming those for my troubles here with these things getting bugged. When we go to 1.1, I might ditch all that. I'm going to seriously look at what I have installed and try and get very, very minimal and use stock parts as much as possible, as much as I hate how they look. Okay, so really all this stuff just needs to fold up above this probe, so that's what all the rest of this is for. We've got these electric ion engines here attached to the outside with more fuel tanks, and these nice structural pieces which are radial adapters that come from near future construction, I believe. And then on top of that, I've got a lot of robotic parts here from the Infernal Robotics pack. A little adapter, we got a hinge, we got this nice truss, another hinge, another adapter, and then the actual sensor sitting on top. This is the stock survey scanner. And then from ScanSat, we've got a couple other sensors here. We got the altimetry sensor, the radar altimetry sensor, so these two kind of work together. I probably don't need both of them on one satellite, but hey, what the heck. And then the multispectral sensor, which scans for different, I don't even remember what this thing scans for. Ore and whatnot, probably. Gosh, I'm such an authority on this, aren't I? And then over here, got the big communications dish. So remember, there's no communications network out at Lathe, and there's a time delay out there of several minutes. So I won't make that investment until I know there's something to invest in out there. So I want to send this out, look for resources. If it's found, then I will send ComSat. So this thing's on its own. So this big dish here has to send, keep connection with this all the way back to Kerbin. Now, ion engines use electricity, so out in the area, out in the vicinity of Lathe and Joule, there's very little sunlight, so that's why this is really overpowered when it comes to solar arrays. And then in addition to that, I stuck on 4 RTGs. So hopefully this will have enough electricity. See, the thing is, these ion engines don't produce a lot of thrust. They'll take, it's burn to enter orbit is going to take 20, 30 minutes. So if you run out of power, then you got to just shut the engines off, let the solar panels recharge the battery, and then fire up the engines again. With the RTGs, they produce constant electricity no matter where they are, so they're great for deep space probes, and that will help us immensely in getting into orbit. And also along those lines, I've got 4 engines on here, so that will give it some more push. Oh, before I move on, one other thing I forgot to mention is that this thing's way out of balance. You can see the center of mass is over here, so this engine is set to 66% maximum thrust. It will still be out of balance, but at least this guy here, the stabilizer, will be able to, the reaction wheels will be able to keep it from spinning out of control. This was more balanced when I had a heavy sensor sitting right here, and that's now gone. So when that part was removed, I had to quickly replace the Surveyor that was in orbit with a new one, and I didn't redesign it. I left it the way it is, so now it's even more out of balance. So that'll be fun once we get there. Now, I have redesigned this satellite for Duna. Let's take a look at that. Okay, this is the one, the Duna redesign, and you can see this is obviously considerably smaller. I don't need nearly as much delta V to do stuff around Duna, and I don't need the big old battery pack either, so I shrank those down. I moved the engines lower against the body so that this isn't hanging down so far. And then I also obviously rearranged these dishes. So we've got the scanner here. We've got, this is the communications. And it looks like the animation's broken on that. And I mounted the communications on a hinge and a rotator so I can actually kind of, role play pointing this back at Kerbin. And that also solves all of the imbalance problems with this thing. This thing's perfectly balanced, so that will not be a problem. What else is different? I shortened the arms a little bit because without the big dishes, I didn't need to get stuff, up in here to pack it up. So nice, light, small package. All right, now for the space station. Okay, this is what I'm aiming for. If you've been watching this series, you will recognize these. These are all second stage components of my main launcher. Right now, there are only 3 of these up in orbit. And as I continue launching, more and more and more of these are going to go up. And the final configuration should look something like this. This is 389 parts. Cost is 2.48 million in funds. And it weighs 700 tons right now. So this represents an enormous investment. It's great that pretty much all this stuff is going up there for free, or at least the main components are. So you can see I'm not done yet. This right here is the main problem I'm trying to solve right now, which is how to get these to line up when they arc around into the circle. So I'll talk about that in a minute. Now, so I've been looking on Wikipedia, and there's a lot of data on ring stations, and one of the big challenges with ring stations is that they need to be huge in order to work properly. If you have a small one, like let's say I only came out 2 of these sections and then went around, you get 2 problems. One is that there's a significant change in the apparent force along the outside. You're trying to create gravity. There's a change in the gravity from your toes to your head, and that I think creates some physiological problems I was reading about. So by making it really big, your height is a smaller and smaller percentage of this total distance away from the center. So you feel a more consistent force against your feet. Number 1. Number 2 is progression. If you were to take a bicycle tire and spin it while you're holding it near the hub, what you would notice is that it tends to want to kind of torque around a lot. I can't remember what the phenomenon is called or why it happens. I can't really explain that, but I was reading that the way around it is that, like here on Earth, if we were to build a space station that didn't progress like that, it would have to be 224, I think it was meters across, which means that to create 9.8 meters per second of acceleration, which is what gravity does against your feet, then it would only have to rotate at 2 RPM. So that's a pretty slow rotation. That means it's not going to progress a lot, and that's enough for systems to keep it in one place. And the reason why you don't want it progressing is basically to keep it stable, so that solar panels can be pointed where they need to be pointed, dishes can point where they need to point, and if you have docking nodes, they will stay in one place for your ships to dock onto. Now, if you want to build something like that yourself, the most important component is probably this one right here. This is what creates the angle. So I've got a second stage tank here, and this angle is what's going to be creating that circle, making those things arc around. And there's a nice little thing here in KSP, which is that if you turn on the angle snap and I were to go to rotate this one click, that's 15 degrees right there. And 15 is an awesome number. Here is why. The circle is 360 degrees. You divide that by 15, you get 24. So it's going to take 24 of these segments to make it all the way around the circle. And that's nice because no matter what symmetry I use here on the spokes, you can't see it here, but your choices in KSP are 2, 3, 4, 6, and 8 for symmetry. I want to go with 3 spokes. I can't cram any more of those onto the hub. They're just too big, so I'm going to go with 3. Actually, I could do 4, but I just like the look of the 3 better. So 24 is evenly divisible by all of those numbers I just mentioned, 8, 6, 4, 3, and 2. So that means I will have an exact number of boosters, second stage segments, attached between those spokes. If you went for an odd number, you would have lots of problems, right? So 15 degrees is what this is right here, and that will create a ring of some diameter. I don't really know what that is right now. It's actually very hard to even calculate that here in the VAB or in the spaceplane hangar. So then the other question is, really the big variable is how long the spokes are going to be. If the segments on the ring don't match up, like I showed you before on the ring I just built, then I just need to increase or decrease the length of the spokes so that those ring parts line up. Okay, here is the hub. This is the exact same fuel tank. I have sized up these radial attachment points and then attached the large docking rings, the same size I use on these, or on the second stage components to the outside so they can dock up to this. And then on top and on bottom, what I did was I placed a docking washer, and it's free moving, so I'm hoping. Okay, I'm not sure if anything's missing. It didn't crash, it just froze for a minute. So where was I? The docking washer. So I'm hoping is that this hub will rotate. Anything attached to these will stay stable, which means I can attach lots of docking nodes for different sized ships on those, and those will not rotate. If you've watched Space Odyssey 2001, you'll see a space plane coming into dock at a rotating station. It's an awesome sequence, by the way. And what they have to do is actually match the station's rotation. That looks like a huge pain in the butt. I would rather just have it be stable in one place. All right, now the last problem to solve is the part count, and that's purely just game mechanics. Right now at 389 parts, if I put this into orbit and tried to get near it with another craft, I would probably be getting a couple frames per second. That's just completely unacceptable. I can't play like that. So I'm going to have to combat that in some way. And what I'm going to try first is part welding. And what I'm hoping, you're not supposed to do that with docking nodes, but what I'm going to try and do first is just get all of this into a single piece. That way this would drop to 30 parts or something like that. If I can't do that, then what will happen is the docking nodes will have to be 2 pieces, and they'll have one in the center. At least I'll remove one of these, which will remove 40 or 50 parts, and I can probably weld together these joints as well. So that would also eliminate about another 50 parts. So I could probably get this down to maybe 200 and something parts. Okay, let's weld this hub together. We got the basic fuel tank here. First thing I'm going to do is I'm going to put a probe core on top. This will become part of the final assembly. I'm going to hide that in there. And then what I'll do is I'm going to do the weld with all nodes shown, or all nodes included in the weld, but I'm going to delete out the nodes for that probe core so that anything connecting to this actually connects to the tank. Next we have the radial attachments. Size these on up. Now I do want to get these in the middle, and I created this nice little sub-assembly here that will help me do that. Use it kind of like a measuring stick. And now if I go look over here, got a nice little X there in the middle, and I can align it up right in between the two lines. And get rid of those. And there we go. Okay, so you click on the weld, made sure that it was going to include all nodes. Select the part branch here. I want the root branch. Weld it. Give it a name. Give it a title. Description. Okay, that's done. Now I'm going to Alt-Tab out, go to my code editor. This is called Sublime Text 3. Open up that part. Those are the nodes I'm going to delete there. I don't need the probe top and bottom. And then further on down, I'm going to delete the fuel, liquid fuel and oxidizer from the fuel tank. This is not going to be used as a fuel tank. I'm going to play it like that would be filled with extra structure because this has to hold the entire stresses of the many-ton ring going around circles. So I saved that file. Next thing to do is to reload the database. This is a quick way to reload all the parts without having to reload KSP. You hit Alt F12, switch to Database tab, then click Reload All. And I cut out about a minute there loading, and then here we are, all done. Go back into the VAB, go look in my parts list, and here is the final part. That's all one piece now. So now I'm going to build out the rest of it, which is just to add in the docking nodes and washers. The little red marker there shows you which side of it is for the piece that should be not rotating. And then now all I need to do is put on the docking rings. Okay, now this piece is ready to go. For some reason it did not take my edit. I am not sure why. I'll have to figure that out later. Now next step is to turn this into a subassembly so that I can attach this to the bottom of the satellites here. So I'm going to attach that, change the root part, and then go like this. Station hub, 5M, 3X, save. Okay, now I'm going to load the satellite. Okay. Drop this in underneath it. And now build the booster underneath that. Okay, so that's the entire payload. So the payload will be 19 tons. Stage 2 booster. Stage 1 booster. These are all built in the same way. Now I'm going to pause the video here while I hook up some struts. All right, here is the completed launcher. All the fairings are attached, got everything strutted up, fixed the action groups, fixed the staging, and it's ready to go. Time to roll this on out to the launch pad. All right, here we are on the launch pad. Got a nice morning launch for you. It stations up at 100 kilometers. I've got it targeted. When it gets to about 90 degrees overhead, I'll go ahead and launch. This will be going into a low orbit, very quick parking orbit, and then I'll boost it up to rendezvous with the station with a timed Hohmann transfer. All right, throttle up, SAS on. Take a deep breath, and here we go. Having a bit of trouble steering this. Can't quite get it to pitch over. There'll just be more work for the upper stage here. Alright, time to stage. Pretty inefficient burn here. See if I can't get my orbital velocity up. Throttle back while I ditch the fairing. Alright, 80 kilometer apoapsis. Will be good enough. Circularize up there. "16-second burn, 54 seconds. I should open up my solar panels and stuff. Let's see. Stage 2 comms, stage 2 solars. I guess I don't have an intermediate range antenna on there to use. Okay, here we go. Throttling up. Okay, orbit is 79 kilometers by 86. Not too great a circularization, but it'll suffice. Next thing is a Hohmann transfer. And it's kind of late, I need to get to bed, so do this the easy way. And this engine's capable of 8 Gs. It's hard to manage throttle when it's like that, so I'm going to cut this back to about 25%. Do about 2 Gs, it should be good. Alright, I think it's time to cut this short, hitting 27 minutes. The rest of this took me several hours, and I'm going to distill that down into a nice cinematic rendezvous, docking, and building out that station. So thank you for watching, and as always, fly with confidence.